So I'm just going to set it up for you. So number 11, to get the answer that's on your daily practice is x squared minus 5. Okay, so I'm just going to set it up for you. You could use the square root, but I think the x squared and the inside of this is going to be easier because the derivative of x squared will give you 2x, which means it'll go away. So when you solve for dx, you get 1 over 2x du. And so, not writing the boundaries yet, you have 2x over, I'm going to put it u to the 1/2, because I'm going to have to eventually do that anyway. And then 1 over 2x du. The 2x's cancel, okay, leaving you with u to the negative 1/2 du, because I don't want it in the denominator anymore. The only thing you have to do from this one is figuring out what the new restrictions are. So 3 squared is 9, minus 5 is 4. And when x equals 30, you're going to plug that in and, oops, not 30, square root of 30. Square root of 30 squared is 30, minus 5 is 25. So that'd be your new restrictions. And from there, I think you can integrate it. Okay, so you're just going to integrate it, not plug the u back in, and then plug these in for u. So these are actually getting plugged in for u. Okay, because we're integrating with respect to u, and by doing this, we don't have to put the x's back in. All right, so that's my help for, or hint for 11. Make sure you change number 11, like I said in the messages. 14 is probably tricky, so I'm probably going to go all the way through with this one, so good question. This is just like that special case that we did that separate video for. So I'm going to do it just like I did in the video. I'm going to take 2x plus 1 in the situation with the square root, knowing that that's the same thing as 2x plus 1 to the 1/2, and this is actually the exact same problem. Number 14 is the exact same problem as the video I did in the thing. The only difference is 4 and 0. So actually, I'm not going to do the entire thing because you have an entire video dedicated to it. Oh, my aunt shared a post of mine on Facebook. How awesome. Not really. So dx would be 2 square root of 2x plus 1 du. Okay, you can go away now. Close, thank you. All right, so I'm just setting this one up because there's an entire video dedicated to number 14. We just have different restrictions. So you would have x over u, and then we're replacing the dx with this, and you get 2 square root of 2x plus 1 du. Okay, and this is where in the video I told you that we actually know this right here is u, right here. So we're going to replace it, and I'm also going to kick the 2 out in the process because I can. And so you get x over u times u du. The u's go away, giving you a 2 in the integral of x. And if you remember in the video, I said the issue is you can't integrate with respect to x. So you would take the u equals the square root of 2x plus 1, and you have to solve for u, or solve for x. And then, I think I wrote this exactly the same in the video, you're going to have to plug in 0 and figure out what u equals. If you plug it into here, you get 2 times 0, which is 0, square root of 1 is 1. And then if you plug in 4, if you plug 4 into here, you get 8, plus 1 is 9, so you get the square root of 9, which is 3. So your new values are 1 and 3. So I'm not going to take this any farther. You need to solve for x. Sorry, Katie. I already did this problem. Okay, technically. Solve for x, plug that in, and then integrate it. And if you have any questions, go to example number 2 on the YouTube channel. It's done exactly the same, just different numbers here, okay?